All right, so it is now in this case it's not the winning percentage, it's like the made serves percentage. So what we want to do is figure out what those are. So as Eric said, we're going to figure out made serves, and that's when she's hitting into the win. Okay, so into win is 20. She made 25 out of 31 serves. If we do 25 divided by 31, yeah. So we do 25 divided by 31. We're going to get 80 or 0.806 is equal to 80.6%. Okay. Then we also need to find the made serve percentage. And we're with the win. All right. With the win means, anyone know what with win means? It means that when she serves, the wind is like pushing the ball, it's behind her. So like she's hitting the ball the same direction as the wind's going. So 27 divided by 30, just like Ernie said. 27 divided by 30 is equal to 9 or 0.9 is equal to 90%. All right. So, Janida, how do we find our test statistic now? Subtract what? And why do we do it that way? Because it's saying, do these data give convincing evidence that actually serves better with the wind? So since we're saying with the wind, we're doing with wind minus into the wind. If it says, does it give convincing evidence that actually serves better against the wind, then it would be this minus that. Right? So with the wind minus into the wind, so it's going to be 90% minus 80.6%. And that's going to be equal to 9.4%. That's our test statistic. All right, so again, what we said. Alright, so what we have here is saying to interpret this p-value. P-value of 0.16 tells us that 16% of our simulations had a test difference that was equal to or higher than the actual test difference of 9.4%. Alright? Yeah. That's like the actual interpretation part of the p-value. Right? All right. So, so that's the interpretation part. Now, the part that I think that you guys are more comfortable with is drawing the conclusions, where you have those 3 guidelines. All right. So, does anyone remember what the 3 guidelines are? So if it's below what? All right, so if our p-value is below 1%, okay, what's the next one? Our p-value is between 1 and 5, so it can be equal to 1%, right? So between 1% and 5%. Above 5%. Greater than or equal to 5%. Alright? So, those are our two guidelines. Good. Now, here's the tricky part. Well, actually, this is the easy part. So, 16% falls where? After, so it falls in this third category. The p-value is greater than or equal to 5%. Okay? So, what we do here, we now know what this is. Does anyone remember off the top of their head what the conclusion is? James? Second one? Nope, not because our p-value is 16%.
You reject the null hypothesis because there's no convincing evidence that whatever is equal to.
So, this is why I give you guys that. You have it in the notes. Alright? So what we do is, since it's greater than or equal to 5%, it's greater than 5%, what we do is click here into the note. Alright? Since it is greater than 5%, we fail to reject. You want to write this down. We fail to reject our null hypothesis. Yes, it's still part of the law. We fail to reject our null hypothesis because there is not convincing evidence to support that she serves better with the wind. Want to write it down? Okay, so since our p-value is greater than 5%, we fail to reject our null hypothesis because there is not convincing evidence to support that she serves better with the wind. I have questions about that. Okay. So again, what we want to be able to be good at doing now is determining whether or not we can say what our conclusion is, determining what our conclusion is, and also being able to interpret what the p-value actually means. What is it telling us? All right. So we have two last things to sort of look at in terms of do stuff right now. All right. So what we're going to do first is we're going to take a few notes. We'll do an activity with the iPad. Take a few more notes, and then do another activity with the iPad. So first things first. Before you write anything down, I want to talk about this first. I'm going to show you what you need to write down. Okay? So here's the deal. On your guys' homework, and on your guys, I'm just saying on your homework in general, and on the problems that we do in class, typically we do about 25 to 50 to 100 simulations, where it's still easy enough for you to count the dots, right? Okay. So here's the thing. We're going to use technology, iPads, to be able to do more simulations. Because what happened when we first worked with this type of problem is we were looking at the performances of the Arizona Cardinals in 2008. All right, and we're looking at their wins at home and on the road. And what happened is we didn't find convincing evidence that their ability was greater, meaning we did not find supporting evidence that there was home field advantage. All right, if you ever play a sport or you ever watch sports, you always hear them talk about home field advantage. So it must exist, right? I mean, they wouldn't just talk about it, it's not something that's like actually exists. Okay? So it seems weird that we found out previously that it didn't exist. Okay? Well, why was that? Well, the thing is, all right, our sample size, which you're going to write down the definition of in just a second, our sample size was very small. We looked at one season. One season is 16 games, and we only simulated it like 500 or 50 times or 100 times, probably two. That's not many games. 100 simulations, that's like 1,600 games. All right. Yeah, that sounds like a lot, but that's not really a lot. All right. So what we want to do to get a better idea, to sort of get a more accurate conclusion, is we want to increase our sample size. All right. And the sample size is equal to the number of observations. All right. For example, the number of games, the number of shots, the number of at-bats that we are analyzing. Yes, you're going to write this down. So what we want to do is, when the sample size is larger, the effective random chance are balanced out and the team's performance will be closer to its ability. So what it's saying is, when the sample size is small, random chance has a larger effect on the simulations, has a larger effect on what happens. But the larger you make the larger and larger your sample size gets, the more and more that the random chance is balanced out with, the actual ability. So what happens is the actual performance starts to resemble and be closer to the actual ability. Okay? Yes, you need to write that down. That's the definition of sample. As we increase the sample size, though, it becomes increasingly difficult to do these problems with our hands. Can't do it on paper anymore. Wake up, man. Okay, so we can't do this stuff by hand anymore. We have to learn how to use technology. Alright? So what we're going to look at is this. Now I want you to write this down. Okay? We have, instead of looking at just the 2008 season of the Arizona Cardinals, I want you to write this down and the hypothesis down. Instead of looking at just the 2008 season, we are going to take the 2004 season all the way to the 2008 season. Meaning, we're looking at 2004 season, 2005 season, 2006 season, 2007 season, 2008 season. 5 seasons. Okay? So we're looking at this information. Now we see at home, they had 23 wins, 17 losses, and 40 home runs, or 40 total home games. On the road, they had 10 wins, 30 losses, 40 total games. And they had 33 total wins and 47 losses, and 80 total games. So we've increased the sample size now. Okay. Now, our null hypothesis is now going to be 2004 to 2008 Cardinals had the same ability to win at home and on the road. Our alternative hypothesis is 2004 2008 Cardinals had a greater ability to win at home and on the road. So what we want to do is test these hypotheses. We want to figure out, does home field advantage, is there convincing evidence that home field advantage exists for the Arizona Cardinals? Because it looks like it was. They're 23 and 17 at home versus 10 and 30 on the road. And I just want to throw this out there too. Any of you guys watch Monday Night Football? None of you watch Monday Night Football? Sometimes? Last week, in Monday Night Football, the Arizona Cardinals playing the Pittsburgh Steelers. There is a stat on the screen that underneath their current coach, which is like over 4 seasons, so since like 2011, the Arizona Cardinals were like 49-12 at home. All right, might have been a little bit different. It might have been like maybe like 40-12. All right, they were like 40-12 at home. Now the Arizona Cardinals in the past 5 seasons, they haven't been Super Bowl winning teams. But like a record of 40-12, 35-12, something like that, that's a pretty good record. That must mean on the road they do pretty bad. Because they aren't making the playoffs. They have not been good. So everything's sort of pointing to the fact that there is evidence of home field advantage. However, in the past study we did, we got stuff that said that there really wasn't. So now what we're going to do is, instead of looking at an example or a sample of 1 season, we're going to look at a sample of 5 seasons. And we're going to do a lot more simulations. Okay? So, what do we need to know in order to figure out, so we're going to get a dot plot, right? In order to read the dot plot and get our p-value so we can make our conclusion, what piece of information do we need to know before looking at our dot plot? The test difference or the test statistic. So, how do we figure that out? In this case, it's home winning percentage minus road winning percentage, which is what we did here. Home winning percentage was 23 divided by 40 because it's the wins divided by the total. And then road wins, winning percentage was road wins divided by the total. And then we subtracted that. Good. Now, what we're going to do, we're going to get the iPads out. Okay? And I'm going to have, how many do we got? 5, yes, 5. All right. Naya, iPad. iPad. Just start passing the iPad the other way.
That one might still need to be charged.
iPad. There's 5 of them that say 5. How many we got out there? Who else still needs an iPad? Just 2? Someone help him. Here.
So that's going to be charged.
Alright, so I need you to log on to the Wi-Fi if it's not already. And I need you to, after you're done log on to the Wi-Fi, I need you to go to the home screen. Meaning just don't go into any apps or anything. Okay. You guys all already logged on to Wi-Fi? Okay. So, what you're going to do, everyone's going to get on the Wi-Fi, right? Okay, so what I need you guys to do is I want you guys to click on the thing that says statistical reasoning. Okay? Statistical reasoning. You guys all click on it? Okay, are all of you guys on a screen that looks like this? You guys see a dot plot on your screen? 2137. Okay, so I need, if you're not on this screen, I need you to click on this statistical applets up on your iPad. See that? Does that take you to this screen? You all here now? Juan, you here? Janaya, you here? No, where you at? Back in what? Wi-Fi? Ernest, you here? Huh? Statistical reasoning and sports. And James, you there? All right. So what I need you to do is I need you guys to click on difference in proportions. All right. So what we now are going to do, so you see you have context 1 and context 2. All right. So what you're going to do is notice it says the Cardinals had a greater ability to win at home than on the, Janai, you have a question? Hit statistical applets. And then hit difference in proportions. Yep. All right. Give me 1 second. So it says had a greater ability to win at home than on the road. So we're comparing home to road. So what we need to do, since we're comparing home to road, home is going to be our context 1. Road is going to be our context 2. So it says successes, right? You guys all are looking at this on your screen now. Okay, it says successes. In football, and in this situation, a success is what? Wins, right? So successes are wins. So in context 1, how many home wins did they have? So type in 23 there. How many total attempts, meaning total home games, did they have? 40. And for context 2 is what? Our road games. So how many road wins did they have? 10. And then how many total attempts did they have? 40. So what I want you guys to do, before you do anything else, I want you to click calculate observed difference in proportions. You guys see these numbers? Well, you guys might be a little bit different. You guys are probably decimals. So you guys see 0.575, 0.25, and 0.325, right? That's fine. Just know that it's the same as percents. Okay? Now notice, if we go back and look, home winning percentage, road winning percentage, and our test statistic. These 3 numbers are what? These 3 numbers, right? So when we start doing this on the iPad, it calculates your test statistic for you. It calculates your winning percentage and losing or your winning percentages here as well. So here's what we want to do. We want to simulate. Okay, you want to have a large number. So instead of 100, we can count the dots. So instead of 100, let's put 1,000, because 1,000 would be that'd be 40,000 games that we just simulated, and that'd be 1,000 seasons that we just simulated. So go ahead and type 1,000 in. You can pick any number. You can pick any number that you want. You just want it to be really big. So you can pick 2,000. You can pick 10,000. You can pick. The larger the number, the more accurate your data. All right. So what we do, we're gonna hit. So now you're gonna hit add more trials. So you get a graph now, right? All right. Now notice, we did 1,000 simulations. So that means there's 1,000 dots on this graph. So you can't count the dots, right? You can't really see the individual dots. So before we do anything else, you guys need to write them down in your notes so you can follow along here. right? So each dot represents one simulated difference in proportion of winds at home and winds on the road. All right? Yeah, write that for your dot plot. So we're looking at this dot plot. I know you guys don't have a dot plot in your notes, but what I want you to understand is that each dot represents one simulated difference in proportion. Why are you guys sneaking around the corner like that? You're not spotty, you're not doing what you're supposed to do. Okay. So, and then I want you to put on your paper, our p-value is blank. I want you to draw like a little line for fill in the blank there. Okay. Now, your guys' p-value is going to be different than my p-value. James's p-value is going to be different than Ty's p-value. Your p-value is going to be different than, I'm saying your name wrong, aren't I? All right. Tay? Dantea, okay. Why don't you correct me like the fourth or fifth time that I said it? They'll be used to it because I'm used to people saying my name on there all the time when I was growing up, and I corrected it. So we're going to call you, no, I'm just going to call you Dantea because I'm never going to remember to call you Tay. Because I'm talking about basketball coach. So we're going to call you Dantea. So Dantea is going to be different than Jania's, and Janiah is going to be different than everyone else. Okay? So, we want to figure out what our p-value is. So, can you remember how to figure out what our p-value is? Huh? So we use our difference in winning percentage, and then how do we use it? So what was our difference in winning percentage?
16%.
Our difference in winning percentage is 32.5, right? So yeah, 16% was the warm-up. This one's 32.5. So what we're going to do now is we go to our dot plot. And now we're going to find, what line? Not sure why mine is cut off on the bottom like that. But I'm looking for 32.5. You guys are looking for 0.325. So what you probably see is this. You guys probably see like right here, 0.3, right? Your guys look a little, let me redo mine so I can have it look exactly like yours so we don't get confused here. All right, so let me do this real quick. Hold on one second. All right, what was it, 23 and 40? 10 and 40. All right, so this look better? So that looks more like your guys's. So what we have here is we want to find
students and staff. I apologize for not getting.
So what we need to be able to do is we need to figure out what our p-value is. And again, I don't want to make you guys count those dots, and plus you can't even see the dots to be able to count them. All right, so what we need to do is maybe take advantage of the fact that we're using iPads. So if you look at your screen and you go down to the bottom, you'll see something where it says count the number of dots less than or equal to blank, right? See that? Now we don't want to count the number of dots less than. So first of all, we want to count the number of our dots that are greater than or equal to our test statistic, which was 32.5. So 32.5 is like right here somewhere. All right. So what you're going to do is count the number of dots. Do we want less than? No, we want greater than. So you're going to select greater than or equal to, and you're going to put, now not 32.5, you have to put it in as a decimal, which would be what? Yeah, 0.325. And then you're going to hit count. And you'll see it says something. So mine says 3 dots. All right, yours says 7. What would you say? Would you say right there? You get count? You say 1 dot. All right. So 1 dot. So here's Ernest, what did you say? So 3. So yours is going to be different than other people because it's a simulation, right? Each simulation that one thing, like I do a simulation now is not going to be the same as the simulation I do next, like if I did in past class. All right, so go back here. So our p-value, at least in my case, your p-value is different. So on your paper, I want you to write down your p-value. My p-value was 3, and it's a percent, so it's out of the whole. So there were a whole 1,000 simulations. So my p-value was 3 out of 1,000. Montea's was 1 out of 1,000. This was 7 out of 1,000. Now, this is equal to mine's equal to 0.003. Okay? Yours is not. Yours is equal to whatever. Down there is 0.001. This is 0.007. Ernest happened to be 0.003. And what percent would this be? Well, I do that decimal 2 places to the right, it's going to be 3%. Okay. So now I would use that p-value to draw my conclusion in all of our cases because our percents are very small. All right. It would be we reject our null hypothesis because there is convincing evidence to support our alternative hypothesis. So we reject our null hypothesis because we have convincing evidence to support our alternative hypothesis. Okay? So what that means that this is convincing evidence that home field advantage exists. This is convincing evidence that home field advantage does exist. So, if there really is a difference in ability, we are more likely to find convincing evidence of the difference when we use a larger sample size. I'd write that down because you're going to have some questions on your homework that goes all about it. It might say like, for instance, it says, oh no, that's in the next. No, that's in the next. That's something that we got to do on Wednesday. So sometimes you might see it if I ask, how could you make this simulation better, or how could you get more convincing? Yeah, well, add more simulations, make your sample size larger. All right. So the larger your sample size is, the better, because the performances are going to be more closer to their actual ability. Questions about that? So what we're going to do now is, I initially wanted to show you guys, do an example with you guys and run through all that stuff. On Wednesday we'll do that. And I want you guys to go ahead and I want to log off the iPads. And I'm going to have you guys start your homework for the next 13 minutes. Okay? I do want you to start your homework. Taylor's already finished at least like 2 or 3 parts of it, I believe. Right?